Tech in 5.
In an age where everything is online, how safe are you really? RSA Encryption, a cornerstone of digital security, that revolutionized the way we protect information online. In 1977, three visionaries, Rivest, Shamir, and Adleman, introduced RSA Encryption. This groundbreaking work laid the foundation for secure digital communication, transforming not just cryptography, but also the future of internet security as we know it. At the heart of RSA encryption lies the beauty of mathematics. It tells the tale of a pair of keys, one public, visible and usable by all, and one private, safeguarded and concealed. The public key functions like a padlock. Anyone can use it to seal a letter securely. Once sealed, the lock cannot be opened, even with the same public key. Only the intended recipient, who possesses both the public and the private key, can unlock it using the private key. These two keys are linked by the magic of prime numbers that have fascinated mathematicians for centuries. The RSA keys are crafted from two large prime numbers, multiplied together. While multiplying primes is straightforward, reverse engineering to find the original primes is incredibly hard. The private key contains a unique exponent that, when used on the encrypted message with modular arithmetic, decrypts it to reveal the original message. The security of RSA relies on the practical infeasibility of reversing this process without the private key. You might wonder, if someone could use a powerful computer and brute force methods to crack an RSA key. Theoretically, yes, but even with today's high-performance computers, the time required to crack a 2048-bit RSA key is extraordinarily long, far beyond the age of the universe in years. However, computational capabilities are always advancing, and with them, the feasibility of brute forcing RSA encryption keys evolves. A few years ago, RSA 512 was already deemed insecure. With more sophisticated factoring algorithms, RSA 512 could be broken in just a matter of hours, or even minutes by a well-resourced attacker. RSA 1024 is significantly more secure than RSA 512, due to the exponential nature of the problem. Nonetheless, with the current computational trends, and the potential for specialized hardware, well-funded organizations or state actors may find it within the realm of possibility to break RSA 1024. As of now, RSA 2048 is considered secure, and is expected to remain so for the foreseeable future when it comes to classical computers. Why should you care about the security of RSA? Well, RSA is the silent guardian of our online activities. It secures email communications, allowing sensitive information to be sent across the internet with confidence that only the intended recipient can read it. When you digitally sign a document, RSA ensures that the signature is authentic, proving that it came from you and you alone. This is pivotal in legal and financial transactions where trust is paramount. Then there's SSL/TLS, the protocols that keep your online purchases and banking safe. They rely on RSA to establish a secure channel between your browser and the server. Without RSA, the padlock icon in your browser's address bar wouldn't mean much, and the idea of secure online shopping would be a risky proposition. In today's interconnected world, RSA is more than just an encryption method. It's a defense against identity theft, financial fraud, and data breaches. As we become more reliant on digital services, the significance of RSA's robustness only grows. The security of RSA relies on the infeasibility of reversing this process. Now we must also turn our attention to the horizon, where the dawn of quantum computing poses new challenges. In the realm of quantum computing, the very rules that govern the world of cryptography are rewritten. Quantum computers, with their ability to process exponentially more data than classical computers, could render RSA encryption vulnerable. At the heart of this threat lies Shor's algorithm, a quantum computing process that could factor large numbers efficiently. This could compromise the security that RSA provides, potentially exposing our digital secrets. But the story doesn't end there. Anticipating this quantum leap, cryptographers are already forging the future of encryption, with post-quantum cryptography. In 2022, the NIST selected the first 4 algorithms designed to resist quantum computing attacks. Now, the agency has initiated the process of standardizing these algorithms before these advanced mathematical tools are made available for global organizations to integrate them into their encryption infrastructure. As we've seen, RSA is a backbone of digital security, but it's not immune to the tides of technological change. The quest for quantum-resistant algorithms is well underway, ensuring that the future of our digital privacy remains intact. Remember, the field of cybersecurity is ever evolving, and staying informed is key. Stay tuned for more videos on Tech in 5.